just joining.
All right. Hello, everyone, and welcome to Cube Simplify. Yet another day and with another amazing workshop. That too with my friends at Dagger, Kyle, and yeah, Solomon is just joining in. So this will be a pretty interesting stream. So please say hi wherever you are joining in from. We do want to have more and more questions that you will be able to ask. So that's why it's kept live. And yeah, so it's live, and you'll be able to ask the questions, and then I'll put off the live stream, and then we'll re-upload it as a video. That's how it will be. So yeah, some people have started to join, which is good. And Solomon is here. I'll pull him on the main stage now. Hi, Solomon.
Hello.
How are you?
Great. Thanks for having us.
Awesome. So yeah, today is very interesting stream because we are diving into the area which is very hot on the market. People are buzzing about it. People are talking about it. And the Dagger team did a lot of stuff in the past 2 months. I mean, they might have been doing a pretty bit earlier as well, but they have been showcasing. They started showcasing this in the past few months, and it has got a crazy response. I reached out to Solomon. He never says no, which is very good. And here we are. We are post KubeCon, which is amazing. So KubeCon was busy, and I'm pretty sure it was busy for Solomon and the Dagger team as well, talking to a lot of people, customers, community. And now we are back. I think Solomon is still not there yet. He's still in Europe somewhere. But yeah, I and Kyle are back home, and we are happy to do this particular workshop with you. So today we'll be talking all about AI agents. Yes, we will be talking about AI. We'll be talking about AI agents, and we'll see how we can build something from scratch, which is the crux of the whole workshop. So yeah, Solomon, let's start with the very fundamentals, like the very, very basics, because I love when you start explaining things in a very, very basic way to a person who doesn't know anything. What the hell is AI agent, and why anyone should care about it? Like, why should we even care about it while we are talking about it?
Yeah. So, by the way, I will say that today I'm a co-pilot. Kyle will be the pilot here in this session, and we're just gonna tag team this because he's given a bunch of workshops on the topic of AI agents and how to build them with Dagger. Yeah, an agent. The short version is AI agents are the most exciting thing happening in AI right now. We think of it as the second phase of this AI revolution, right? Of course, the first phase was these models exist and you can talk to them and they can talk back, and wow, they're super smart, right? And the second phase is that the AI can now do things. It can interact with its environment. It has that capability. You just need to give it the tools to do that. And that's what an agent is. At the broadest sense, an agent is an LLM connected to some software so that the LLM can do things itself. It decides to do things and then it does them. But of course, it does that in an environment controlled by you, the developer. And that's why this is so exciting, because building an LLM is something that most developers will never do. It's a very specialized, elite job to train a model. But building software is something that we can all do. So agents means that now we can build amazing new software that has this amazing brain inside of it as a component, right? So that's why we're all so excited. I want to build an agent, right? I want to build a super smart robot with a brain that can do amazing things. It's the next generation of software that we have a chance to build. So that's what an agent is.
So you mean to say, like, we have basic stuff, which is like, all the big LLMs which are already there, ChatGPT, which is powered by the GPT, and then we have Llama and all these that are able to do all the tasks. Like we give them input and they are able to answer us back. And obviously, if it's not a garbage input, then we do not get a garbage response. We get a good response. So better we are at the prompting, better we get. But now agents is a specialized piece of LLM, or maybe they are smaller LLMs. How do you categorize it? Are they smaller LLMs which are out there, and then they are connected to your piece of software? For example, they are connected to Prometheus, and the agent is able to run the PromQL queries on the Prometheus that you have, and then it passes off that information to the next agent, which is specialized in its own way, and that's how you build a relationship between the agents, and every agent is able to do their specific task. Because when you were talking, I realized that there was one specific company, I don't remember the name, that talked about AI agents, and specifically the SRE agent. So that means the SRE agent is someone who is monitoring your particular system or has access to all the systems that you're having while your LLM is running locally, and it is able to query that just as a human does, and then it is able to give you the output in a more human readable formats, or even take actions, or even send it to the next agent.
Yeah, I can jump on that if you want. So, if you think about the LMs themselves, like you said, GPT-4o, all these different models, those are the brains. And so when you talk about using something like ChatGPT, where you're just talking to this generative model, and you're giving it some text, and it's thinking about what you said, and it's giving you some text back. So that's just one component of the agent, is that ability to receive some input and figure out some probabilistic output for that input, right? So when you create an agent, you actually combine that with an environment where you have a bunch of tools, like you said, Grafana, or some way to monitor your platform, right? And so you give it these tools where you could say, like, here's a bunch of API endpoints where you can check on the health of your application or something like that. So now combining these two units, the environment and the brain, you can create this little box where we call that the agent, where it's just running in this thing and it's saying, okay, I'm checking on this. The health of this app looks good. Let me poke around, and it can explore and use those tools that you give it. And it's interesting, if you look at how Anthropic talks about agents in general, is this distinction between like workflows and agents, where you might have a workflow where you say, I give my LLM like a PDF and ask it to summarize it. And that's like a strict like input, output. There's this one step in the middle that requires some generative capabilities from your model, and it might have tools to read that PDF, or you just give it the file, right? And so that's just a workflow. The agent is this kind of more open-ended, like, we give it a bunch of tools that it might need, but we don't necessarily have this predefined flow that it's going to take. It just has this toolbox and a primary objective, which is like monitor the health of my application or create a program that does this thing, and it can work within its own little box until it's completed its task, or maybe it's like a endless task, like constantly monitoring your app. And that's where you just give it these tools, and it chooses its own path through this world.
So quick follow-up question on that. So do you fine tune the LLM that you are using on the basis of the software that you are connecting it to? Because you mentioned something about tools, like you don't tell the workflow, you let the agent decide its own path. So how does that kind of work? Like, how do the agent connect the dots? Because they, right now, if when you connect, so how you start building that whole relationships with that particular the software. Like, you have the agents and you are connecting them to a piece of software, and it has access to all the tools, and how does it define its own path?
Yeah, good question. It's part of this, like, this breakthrough, this big new wave of all these new things people are building with AI, is really unlocked by that tool part of the world that I mentioned, where now it's not just writing text; it has these tools, and so part of that tool thing is basically like a built-in protocol where the model itself can say, I have this tool, I want you to run this tool and give me the output of it. Like a common example is you give it a function that says, give me the weather for the city. And the LM sees that that's one of the things it can ask for. Right. And then as it's running it, and you ask it for the weather in the city, they'll say, okay, I need to call this tool. There's some system underneath, and that varies depending on how you're running an agent. We'll show that later on with Dagger specifically, where it says, okay, I need to run this tool and then give me the output of that. And that happens on a system and gives it the output or whatever of the weather, and then it can send that back to you. So that's like the big new thing for tool calling. It's like this built-in thing that a lot of models know how to do. They have to be trained on how to do the tool calling specifically. So there's some models that can't do that, right? And then on top of that, now there's this other thing you've probably seen a lot about called MCP, which is a protocol for kind of expanding that to lots of other types of tools, and creating this kind of interface, this common protocol between your model and all the different services and tools that it can interact with.
All right. So you mentioned a bunch of stuff, MCP and things, which I know, which are buzzwords. We need to break it down. So first is how do you? Yeah, when we got a question as well, can you please share something about MCP? Yeah, going before that, since you have been talking to a lot of customers and you have been giving these workshops and you have been interacting, what are the top 3 use cases that you have been hearing from maybe people or customers or maybe whom with you are doing the POC? What are the top 3 use cases?
Yeah, I can take it, or Solomon, if you want to jump into.
Yeah, well, the at a high level, Dagger has a community of platform engineers, build engineers, cloud engineers, people who assemble the system and keep the system running, right? And a lot of times they're the engineers who serve all the developers on the team and give them tools, give them infrastructure. And we provide that platform team with a system to do that very efficiently. And so a lot of the use cases we're seeing for building agents with Dagger come from that community. And so it's a lot of tasks related to software engineering. Of course, a lot of this comes from coding agents. A lot of code editors now have an AI feature to help you code. So the editor can now generate code for you. And in some simple cases, it can actually just write the feature for you. But if you're building something more serious, what happens is generating codes is just the first part of actually doing software engineering tasks. There's all the work that comes around the writing of the code, right? There's building, testing, linting, asking for reviews, giving reviews, just a lot of tasks that require automation and require an environment to run these tasks in, an environment that's repeatable, it's observable, right? It's portable, because sometimes you want to run these things in CI, sometimes you want to run them on the developer machine. So the use cases we see and the agents that we see people building, there are those kinds of agents, right? Like an agent that will look at your Docker file and optimize it. An agent will review your documentation and make it better, right? Or an agent that will just develop a feature for you in your specific environment, right? With a dev loop that actually works. It can verify itself that the code that it just wrote built, so it has its own dev loop. It's those kinds of use cases that we see the most. And
Nice.
I'm sure Kyle has a million other examples.
Oh yeah.
He's built a bunch. Like I don't know, what's the last agent you were building for yourself, Kyle?
Yeah, I mean, I think my favorite one that I've built so far is like a self-healing CI, right? So your test fail in CI, and then it can debug that failure and then give you the fix for the test, right? Like we already have all these tools, like especially linting, where they tell you exactly what to fix in the output. Why not just fix it? So that's the kind of thing an agent can do in your CI.
Yeah. Well, one that I like that someone in our team is developing, and I can't wait to use it, Uh, it's an agent that will watch your Discord or Slack channels, and then you can ask for it to summarize or tell you what happened today, what was discussed in a thread that you didn't see, that you don't have time to read or catch up with. It just kind of, keeps you up to date. And I know I need this one badly because we have a very, very active Discord server. By the way, you should join it if you're interested in this. Um, and there's so much going on, so many ideas being discussed, so many decisions being made. Um, I just want an agent that gives me the summary for me. We're going to share the link to the Discord server in a minute. But yeah, there's something that you should mention, Kyle, is just how modular this whole system is. It's not just one big agent that you build. It's like a lot of little agents, like a toolbox, and then you can combine them as you need them.
Yeah.
So basically, we are. Yeah, go ahead, Kyle. Go ahead.
Yeah. So like one of the interesting issues today is like this really great emerging technology, and hitting against this wall of the current capabilities of the tools we use, right? So like a lot of these models are really, really cool and capable for simple tasks, but then immediately when you try to do something very complex, a lot of them just fall flat on their face. And so one of the challenges when building agents is kind of narrowing this thing down. And it's the same problem that we deal with for any other application when we're talking about platform engineering, right? Where you don't want to build and deploy this massive monolith of an application. You want to break it up into microservices that really focus on their specific expertise, right? So when you look at building a self-healing CI, for example, that's a very specific use case, but you don't want just like your platform agent that goes out and does all the things. You want all this little army of robots working on your platform with their specific objectives.
So basically, we are building the entire workforce so that we need less engineers, and we'll be the ones who are impacting the jobs, right? So
maybe yeah. I think it's more of like you don't need to have someone watching the dashboard all day because you've got a bot for that. So that
yeah,
person can now go do more effective things with their time within your team, right? They can be enhancing the platform in different ways.
nice. So how Dagger came into this whole equation? Like you have this AI agents concept, which is good, and AI agents building AI agents, which is good. You have MCP, the new protocol, which is coming out, or it is out already, and it's picking up a lot of love from the community or hype. I don't know because I haven't used. So how Dagger came into this whole process and why you thought it would be good for Dagger to build this agent, which we'll go just right after this question, like how we build it from scratch.
We didn't decide anything. The Dagger community decided for us. That they started building agents using Dagger, and then they showed us, and then we thought, oh, that's pretty cool. And then they started asking for features, and then we started designing those features to make it even easier to build agents with Dagger or integrate with agents with Dagger. And that's how it happened. It happened very naturally because the same people that are using Dagger today, they have problems to solve that involve AI agents, right? Either they're interested in using these agents for themselves to save time, or do magical things that were very hard that were very hard previously to automate, or the developers on their team that they're already serving with other tools are asking for agentic features. They want to use AI to develop faster, to be more productive. Or sometimes they're already using AI, but outside of the platform, And so in any case, if you're a platform engineer, if you're the platform team, it's your job to provide the best possible tools, the best possible platform for your developers to be productive. And today that means giving them agents, having an answer to this new set of features. So that's our community. They did it with the tools they knew, and that includes Dagger.
That's so cool. I mean, that's really awesome. That's the power of open source. That's the power of community, and which is why I have highlighted the Discord that you should be joining for Dagger, because that's where the fun stuff is happening. So yeah, I think it's pretty cool. We now know the concept of AI agents, why they are important, and after the whole AI hype, this is the second phase which is happening of the agents, and I have heard it a lot in a lot of conferences, a lot of places. AI agents are the next wave, because it not only is a big LLM that you're talking to and you're throwing the data. They are the bunch of them, like you said. It's a whole toolbox that can do different things. Now you have the whole toolbox with you, and you can pick and choose whichever tool, or AI can pick and choose whichever tool is required for one specific task or other specific tasks. And those tasks that take just useless amount of time, that can be used for n number of other things in improving the platform, or uh, you know doing the business logic, or getting more money for the company, can now be used, and the useless hours can be diverted to these AI agents. So I think that's pretty cool. So yeah, I don't want to waste any time, unless you want to share some prerequisites or pre stuff before we dive right into kind of the hands-on workshop. Like, let's
So yeah,
let's dive into it. Let's see it in action. Let's build the agent. Let's do
yeah.
something.
So this is Cal's workshop. It's he's in charge here. Maybe we should start by telling everyone watching what they're going to be able to build. What will they
Yeah.
have at the end if they follow along?
Yeah, so basically the objective here is to build like your first coding agent. So it's very simple, but you'll be able to ask this agent to write a Go program for you that does a specific thing, and then we'll be able to see the agent actually build this program and make sure that it works and all these things, and then we can use it. So that's the objective. It's really small. It's a toy, but it lets you learn these principles to kind of take them and build your own agent to go do uh, your first enlist in your army of agents working on your platform. So
It's
yeah,
like Pokemon, it's your first
exactly.
Pokemon cards, and then you can collect more.
Yeah. Did you want to show anything with shell or prompt mode before we
Oh,
dive?
maybe let's get started with your flow, and then maybe if
Okay,
you inspire me to show a little thing on the side, I'll be the wingman with my terminal ready to go.
perfect.
And
Wait,
one thing,
are you going to show prompt mode at all? If we is it in is it part of the the flow?
Yeah, I can start with that. Sure.
and also if you can share the link, like how do people follow along? Like if anybody wants to do this right now,
Yes.
what do they do, Kyle? If you can mention, because I would want to do try along. So I'll
Yeah.
on the back, I'll also keep doing that. So if you can
So
tell
I'll put the link
what
over
do we need to do?
there.
Yeah.
So we'll be
Basically, you need
roughly
two
following
things.
this.
Yeah, this is the link. You need to install Dagger, which is a command line tool. Install it on your machine, and you're going to need some sort of an LLM endpoint. It could be a local LLM with an open model like Llama or Quencoder. It could
Olama
be
is
a
fine, right?
hosted. Olama, it
Yes.
works with Olama, yes. So if you have Olama set up, there's a section on that. Or an OpenAI API key, or an Anthropic API key, or a Google Gemini API key. Dagger works with all of those. So if you have an account for any of those, now's the time to go get that API token quickly and set it in your environment while
Yeah.
you install the Dagger CLI. And I think that's all the dependencies. That's all you need to follow Kyle's workshop.
Awesome. One quick thing. So yeah, do the go and start doing the brew install Dagger, and also the getting
Oh,
the API key or pulling Olama. But
Yep.
before that, if you can just spend 5 to 10 minutes in explaining what Dagger is, because some people might just be new to Dagger, and we don't want to, just tell, okay, we are talking Dagger, Dagger, Dagger. Although, if you want a full-fledged introduction and workshop on Dagger, we already did a workshop on Dagger, which is pretty cool, pretty awesome. You should do that to learn in depth. But yeah, people starting out right now, and if they want to build the agent, can they have a quick 5 minute or 10 minute primer on what Dagger is?
Yeah, absolutely.
Sure.
Let's dig into that while people get set up too. Um, yeah, Solomon, do you want to give like the high level pitch?
Sure. Yeah. So Dagger's it's an open source engine. It's basically a tool and a runtime to execute the fundamental tasks that power complicated workflows like builds, tests, deployments, data engineering pipelines, any sort of workflow that involves a lot of complicated processing and data flowing through different processing tasks that you want to run in a very repeatable way, that need to be very reliable and fast because you're running them a lot, like builds, right? When you're developing, how many times do you build every day? A lot. If your build's very complicated, you need to be able to build again and again and again, and for the build to be reliable and fast. Otherwise, what happens? You're wasting time, right? So Dagger executes all the tasks that power these builds. It executes all the tasks that power these tests and these deployments, these complicated workflows, and it does so in a way that's very, very repeatable, very observable, which means there are ways to really see what's happening and why it failed and why it's slow. It's very modular, meaning that you can compose workflows out of little pieces instead of a big monolithic workflow that's difficult to change. Very important when you have lots of different tools that need to be combined, lots of different platforms, and it's portable, which means it runs locally on your dev machine, very important, and it runs in your CI server. And that one's very important because a lot of these workflows, you need to run them, like your builds, your tests, you need to run them while you're developing, and then you push the code, and then again, they need to run on the CI server to verify that you didn't mess up and that it integrates properly. Ideally, you want those workflows to be the same locally and in CI. Otherwise, you have drift. Maybe it worked locally, but it's going to fail on CI, right? Or vice versa. And this is a very common problem, and Dagger solves it. So it's a very versatile modular tool. It works by programming. It has an API. So typically, to use Dagger, a team will write some code. You write the code for the little functions that define each of your tasks in your workflow. Here's the function for my build, for my front end build. Here's the function for my back end build. Here's how to combine them with a third function that combines that does the end to end build, et cetera, et cetera. So it's like Lego. It's like the ideal Lego system for platform engineering teams. Yeah, it's a lot of fun. The last thing I will mention is that it has a whole ecosystem of reusable components. So these functions that I talked about, you can write the code for them, but then you can share these functions in what we call a module. It's like a software package in the language of your choice. We support 5 different languages: Python, Go, TypeScript, PHP, Java. You write your Dagger functions in any of those languages. You package them into a Dagger module, and then you share that module on GitHub, on GitLab, any Git server, and anyone else using Dagger can reuse them. And because it's repeatable and all these functions are very portable, very repeatable, they run in containers. Another team and another machine can reuse your functions, and it just works across languages. And you can build another function that is built on top of the other person's function, and you just kind of keep building more and more complex workflows, knowing that it will not fall apart because of this repeatable foundation. So that's Dagger. You should definitely join the Discord to learn more, because it's just a fun, very active place with a lot of engineers that just love these problems. They love to make their builds and their tests and their deployments and all these workflows very repeatable, and they share information, they share examples. and they love to help beginners. So if you're interested, but you're not sure you're experienced enough or you're good enough or anything like that, you should absolutely join and say hello, and we'll help you get started.
Awesome.
Anything I forgot? I tried to cover widely.
Yeah, I mean, I think that's great. Like to kind of summarize, like at its core, there's these components that are building blocks, and with those blocks, you make your own little collection of these blocks, which are modules, right? So just like building on layers of layers from these core types of building workflows with containers and files and directories. And with that, you can build any kind of composable workflow, like your CI or an AI agent.
Awesome. So now that we have good introduction of Dagger, and yeah, people are joining the Discord community as well, which is good. I hope
Great.
everyone will be getting a
Welcome.
good value out of that. So yeah, let's dive into it. I hope you have Dagger CLI installed. You have pulled a model using maybe the new Docker model runner, or um, Olama, or you have OpenAI API key, or Anthropic, all of the documentation that Kyle is just showing. I'm personally using Olama, so I'll be sticking to that. But yeah, let's see which way this goes. Let's do it.
Awesome. Yeah. Yeah. So any of these model providers work, like Anthropic, OpenAI, Gemini. Um, I love using Gemini because it's a really powerful model that you can use for free. Uh, but you can also run anything that's OpenAI compatible, like Docker Model Runner or Llama. If you're using one of those, I would suggest, like with Llama, for example, there's let's see, if you go to models, you want to make sure that your model, let me zoom that in a bunch. Your model is able to call tools, because that's kind of the core part of using an agent, like we talked about. So within that, they have tons of models on their own registry that can call tools. A really great one for writing code, like we're going to be doing in this agent, is Quen 2.5 Coder. As you can see, there's lots of different sizes of it. The smaller the model, the faster it runs, but kind of the less capable it is. So uh, whichever size, if you're using this kind of model, whichever size you're able to run, uh, go for, bigger is better. So if you're running like 7 or 14, you'll probably be okay. If you're running 3 or lower, you just might need to kind of help the model along with some more prompting. So we'll see what that looks like once we start writing some code. So I have a terminal. I've typed in Dagger, so now I'm in Dagger shell. And I can see by running LLM pipe model that my model is configured. Let me back right out and just see why that happened. I can say echo Gemini API key. And don't worry, you don't get to see my actual key here. This is a 1Password reference.
You had me worried for a minute.
Yeah, we're just gonna show everyone. No, this is just like,
well, that's one way to make sure everyone can follow the.
Yeah, exactly. Yeah, everyone take my key. Make sure you get every little character of it. No, it's secure. Don't worry. But yeah, this is a oh no, okay. There's a reference to the secret in 1Password where I've stored my key, like a responsible key owner. But Dagger itself can use this secret reference with 1Password or Vault and actually connect automatically and fetch the value of this key. So yeah, that's a cool feature of Dagger. That's in the docs if you're interested. You can also just make this the actual value of your key. So you can say export Gemini API key equals foo, like whatever they give you from, and I'll just show you for Gemini, for example. But if you followed that configuration, then hopefully you have a key ready to use. But if I go to AI Studio, this is Google's thing, and I can say, oh, they moved this around. That's it. So get API key, and then you can get a key there. That's something aistudio.google.com. So I've got a key. It's in my environment. So now when I type Dagger, I get into Dagger shell, and I ask for, and you see the 1Password thing pops up. because it's reading the key from my 1Password and it says I'm using Gemini. And so now with Dagger Shell, I can work with all of those building blocks that we talked about earlier. Like I can say container from Alpine, right? So that's just an Alpine container. I can do lots of things with it, like with new file, foo, hello. And now that's a container with a file in it. Not very cool yet, but now let's say I just want to get in the container. I can say pipe terminal, and this is like a super quick tour of like the Dagger shell, so we know what we're actually typing things into. And so I'm literally in a shell in an Alpine container. There's a file called foo with that file we just made. So now it's, if you use like Docker run -it before, it's like that, but now we're able to compose things on the fly. So we can do that with containers, files, directories, and also now LLMs, right? Like we saw when I said LLM pipe model. So we're going to use all these building blocks in code in a minute here to actually write our first agent. But what's really cool is like before we actually write that agent, we can actually start interacting with our model already. So you can see in the bottom of my prompts here, we have this little hint that says if I hit that that key, I can get into prompt mode. So right now I've got the cool little bow tie here that says I'm in like shell mode. So I go over here and I'm in prompt mode. I hit that key. So now it says, okay, this is the model I'm talking to. And I can say, hey, what's up? How can I help you today? So I can say, what's explain Kubernetes like I'm 5, and it's gonna, I'm talking to a model. You can see the avatars, and now if I'm 5, I can now understand that Kubernetes is like a super smart babysitter for my robots. I don't know if that's oversimplifying things or not, but now a 5-year-old can deploy Kubernetes. So anyway, we've got a model hooked up. So this is like when we talked about the tools and the brain. We've got the brain part, so we just need the environment with the tools in it. And so now even in shell mode, I can say like I can make a variable just like you can in any shell. I can say container equals container from Alpine. Okay, now we've got a container in my shell. I can say terminal just like before. Now that's just a variable I can use, right? So my containers in my shell on this part, it's just a tour. So if you're not typing everything I'm typing, that's okay. We're going to get to the code part in a second, but I just want to show how we can now combine that environment with the brain, right? So I have an environment in my shell with this variable, and I can say, please install curl in my container. Okay, we might have to help it along a bit. Let's see. Can you use the container? Okay, it sees it. Okay. And now, how do you like to install curl? Do it. It's Alpine. We're gonna hint along a bit in our. Okay, cool. So now we can see it calling tools. It apologized for its lack of execution earlier, and now we can see it did select containers. So this is tool calling, right? We have our little bot icon doing things. It says, okay, let me select this container, which is our variable. And I'm going to call apk add curl. It says, cool, I've done it. It's in container 2. So anyway, we can do things with our shell, but now let's actually follow along this little guide to create our first coding agent in code, right? So now I'll create a new directory called coding agent and go to that. I'm going to make it a Git directory so we can push it somewhere when we're done. So I can say git init. Okay, so I have an empty directory, coding agent, and I want to create my first Dagger module. And that Dagger module is, like Solomon explained earlier, just like a collection of Dagger functions. And we're actually going to write some Dagger functions that that compose the agent itself. So I can say Dagger init, And now we can choose an SDK. I'm going to use Go. You can use any language you're most familiar with, like Go, Python, TypeScript, PHP, Java. Um, any of those are fully supported in Dagger. We have a bunch of other experimental SDKs. I'm going to type in Go, so hopefully you can follow along. But on the quick start, which I think was maybe linked in the chat, there is actually the same snippets available for each of those languages to make it easier to follow along. So I can say SDK Go, and now Dagger's initializing this thing, and now I have a bunch of generated code in my current directory. And so let's have a look at that. I'm going to pop open my editor and zoom this in a bunch. So it's basically scaffolded us like a starting point for working with a module. So this is just like sample code. We can delete it. It doesn't matter. But now if we go over here and say Dagger functions to see what my module can do, we see that it has these two functions it's describing, which are the ones we have here in code. Okay, cool. So our coding agent is here. Let's clean it up a bit so we can start writing our code for our agent. So we'll delete these functions and we'll create a function called go program. And we don't really know what it's going to do yet. So let's think about that. But let's make a comment that says create a go program, or we'll call it an agent. It's an agent to create a Go program. And so, like I said earlier, our goal is to have this agent take in any task, right? So we want to tell it to like write the next Facebook or something, and it's going to churn with the model and its tools, and then give us back this completed task. So our input is going to be its assignment, and that's just going to be a string. So we have an assignment string. If I can type, nope, there we go. Assignment string, and our output is going to be a container that contains our completed assignment, so we can actually do things with it, like actually run it and see it work. So our output is going to be a dagger.container, and there's our function. So we have like our signature. We can actually start writing some code, and we can look at what capabilities the Dagger client has available to it. So first, let's look at the LLM, the brain part of it. Because remember, we have the LLM and the environment with the tools. So we want to create those two things and then connect them and let it do its chaos and hopefully produce some cool things. So when I say dag.llm, dag is the Dagger client that automatically exists in this scope for Dagger module. And LLM is a type, right? So we have a bunch of types. Like we saw in the shell, I can say dag.container, dag.directory, LLM, etc. So LLM is the brain, and we can pass in a specific model. We can do all kinds of things, but now we've got this thing, and let's say this is the thing doing the work. Now, from here, we could say prompt. So Dagger uses this like builder pattern for actually building up your DAG of operations. So with it's going to be with prompt, with whatever, to basically add things to this thing we're building up. So we're going to say with prompt, and that's where we can actually pass in, like, give me the work or something, right? But now, okay, so let's leave this here for now. We've got an LLM. We've got the brain part kind of stubbed in. We want to start working on that environment part. So another type in Dagger is an environment. We can say is dag.env. And so I get these type hints that say like, okay, this is an environment, and my environment is not just going to find like the tools, but more specifically the inputs and the outputs for our LLM. So we're going to say we're going to give it a bunch of these things, and we're also going to ask it to give us back a bunch of things. For example, I could say with string input, because we want to give it this assignment, which is a string. So our string input takes a name, a value, and a description. So let's type these in real quick, and I'll explain why we're doing this. So the name is just going to be assignment. The value is assignment that we passed in. And then the description is the task to complete. Now, this is kind of cool because we're not just adding a bunch of more words to our prompt to say, you have a bunch of tools, go figure it out. This is actually prompting along with our objects in our code, right? So when it receives this input, it has this descriptor that says what this object is. So when we give it more objects, which we're going to do in a minute, we'll see how this is actually kind of building up our prompt for the agent as we're giving inputs and outputs, which is really neat because you have this kind of this declarative and structured environment that is going to be given to our brain. Okay, so now
one thing I really liked
yeah,
about this model as a user is that like a lot of times when you start building an agent, you do a lot of prompting, and a prompt usually starts as a big, first it starts as a small amount of text and then more text, and then in the end your prompt becomes this huge wall of text. It's not structured, it's not organized, you're just changing it, trying to see what works, and over time it gets more and more hard to maintain. And here we're, instead of starting from the prompt, we start from the inputs, the like Cal was saying, we start from the data, and each object that is given to that is added to the LLM's environment is described. And so really each time you attach an object and you describe it, you're adding a little bit of structure to the final prompt, except now there's a reason for that piece of the prompt, right? This is attached to the assignment, and then there will be other objects. So it brings some structure that is really nice when you're developing, especially when your agent grows.
Yeah, exactly, and it's about to grow quite a bit here. So let's see how we can contain the chaos. So there's the next thing we kind of need with the assignment is now the place for it to do its work, because we don't want it to just generate code, but we want it to actually have the capabilities to build the code to make sure that what it gave us was valid code. And if it wasn't, it can get those errors from the build and figure out what it did wrong and adapt and give us back an actual working program rather than just some generated garbage, right? Like if you've used ChatGPT or any other of these chat interfaces to actually generate code, like how often does it give you something that doesn't actually work? We want to make this agent actually test its code first before it gives it back to us, and then iterate on it to make sure it's working. And so we have a few options of how we could do this, right? We could say with directory input and give it a directory of just a place to create code files, but then we're kind of lacking that ability to do validation on it. It needs to be able to execute programs, right? And so we could give it a directory and a container, or we could give it a cool module from the Daggerverse to work with Go code or something. We could just give it a container and say, here's a place to make some files and give us back this working container. The problem is, and we're going back to what I said earlier about like this, the current state of the art versus the potential of these things we're building, kind of butting into each other, especially if you're working with smaller models or something, is that this is too open-ended, right? So we don't want a workflow like remember earlier we talked about workflows versus agents. We don't want a workflow where it's just a hard to find path where we say execute this one thing and then give me the result. We want this agentic loop where it has a collection of tools and it can figure out its own path. But we don't want to give it a million tools where it would only ever need 3 of those, because it's just going to get confused. Because especially like the smaller the model, the more confused it'll get, because you just give it um, the entirety of a hardware store and say build a birdhouse, right? You need to give it like a couple of pieces of wood and hammer and nails and say build a birdhouse, where that's still pretty open-ended, where it could create anything with that, but we're asking for a specific type of output, and we're not just giving it like a birdhouse kit and say build a birdhouse with that, because that's really boring and that's more like a workflow. So yeah, I just came up with this analogy on the spot, but I think
that's so important.
Yeah,
What Kyle just said is that's a super important part of developing agents, and it doesn't matter if you do it with Dagger or some other tool out there. Every engineer who builds agents, small or large, they have this problem of deciding deciding what the constraints are and finding just the right balance between too constrained, not enough freedom for the agent, and uh, not constrained enough where there's too much freedom and the agent gets lost or confused. And it's really an art. And as a developer, you're always going to be looking for that balance. You'll start somewhere and then you'll add tools or you'll remove tools. The important thing is that the platform you're using should make it very easy for you to make these changes and to iterate and see the result rapidly. Yeah, and in this case, I think where you're going, Kyle, is we're going to go in the route of making it more constrained, right? Giving it less tools,
exactly.
which is usually where you want to start. You want to start with an environment. Does that make sense why it says environment here at DAG and we're creating an environment as in, the sandbox where we're then going to place the robot, and what's inside the environment is that's all it will see, right? If it's in the environment, then the agent can interact with it. If it's not in the environment, it doesn't exist because the agent will be in a sandbox that you control. That's why it's called environment. And Kyle's going for an environment where we're going to give objects that do a few simple things and not too much, knowing that you can change it later.
This concept comes from is oh, I lost my scroll. Okay. So in this Anthropic blog where they talk a lot about this agents versus workflows thing that I mentioned, is this kind of really simplified diagram of an agent where you have a human with some LLM calls, and there's this loop happening here of this action and feedback between an LM and environment. So this is like the key part of building an agent is you need those components, but you also need to define the right scope of your environment. Otherwise, it is like you said, it's a sandbox, right? You have to decide how big that sandbox is, how many toys are in the sandbox to play with, all of these things. So we are going to try to make like a correctly sized sandbox so that even with smaller models and without some crazy prompting, we can actually accomplish our tasks pretty reliably. So let's forget about containers here. Let's actually create our own Dagger module that's going to be this environment or this sandbox with the tools in it to complete the assignment. And going back to like the earlier analogy, this is like giving it a place with the hammer and nails and pieces of wood, but not the whole hardware store and not a birdhouse kit. This is open-ended enough where anything that we give as the assignment should be completable, but not too open-ended where it's just going to get lost every time. So anyway, let's move on with this. So now I'm going to create. Let's forget that terminal. Let's use this one. So I'm going to create basically a submodule with Dagger that is just my little collection of tools that I want to put in the environment. So I can say Dagger init. So remember before when we ran Dagger init, it created the module we're in. I'm going to create a submodule. So I'm going to say Dagger init dot slash workspace. So our workspace is going to be our module with our tools in it for actually developing the code. And this could be expanded to like lots of other use cases, but we're just going to call it workspace. We could call it foo if we wanted to. It doesn't matter what you call it. And again, I'm going to work in Go. So I'm going to say SDK is Go. And so we run this. And now over in our editor, there's now a new directory called workspace. And once again, we have this generated thing that is a brand new module, right? And so I'm going to start by kind of cleaning this up, and we're going to say this top function here describes the module itself, or sort of the top comment here describes the module itself. So I'm going to say a workspace for developing Go code. So this describes what my module is. I'm going to get rid of these functions, and we're going to start with saying our first function is going to be workspace. All right, so we basically, in the tools we want to give it, in all the experimentation I've done so far, it boils down to 3 tools that we need. We need our agents to be able to write files to our workspace. It needs to be able to read files, and it needs to be able to validate the code somehow. So in this case, it'll be like a Go build. So we're going to have read, write, and build as our 3 functions. So read, and this will be read a file. And then let's just copy paste this. Just create our module really quick. This is going to be write, and this is going to be build. So this will be, and updating the comments as well. This is cool because in Dagger, when you create a module, like we saw earlier, everything was available from when I ran Dagger functions. It exposes, oh, what did I do? Okay, we'll figure that out in a minute. We'll scroll up though. So when I ran Dagger functions before, it gives us a description for all of our functions. And this is actually sourced from this comment. And if you look at the docs, there's different ways of doing this in each language for Dagger. But the reason that's important is because the LLM sees that usage as well. So when it sees its little toolbox, its collection of tools, we're helping describe what these tools are for, and it'll see how to use it and all these things. So this is all automatically happening inside of Dagger, exposing each of these functions as callable tools. And this is build the code. So yeah, we'll see this in action once we kind of create some of our code. So let's, in the, oh, what did I just do? There we go. Okay. So first of all, we need some state for the workspace where we're like reading files from, writing files to, and actually building. And so that state could be anything. It could be a Dagger directory. It could be a container. So in this case, let's actually use a container, so that's going to be the thing tracking our state as the LLM's working on its code that it's developing. So in my struct, like my actual object definition, for this thing I'm writing, let's create a container, and that's going to be a dagger.container. So now our workspace has a field. Let's call this something else. We can, never mind. All right, let's call it container. You can name it whatever you want. It's just a variable. So our workspace has a field container. So now when we want to read a file from it, we can say m dot, because this our current like self is m. We're going to say m dot container dot file. So now we can get a file at any path, right? So this is just chaining the functions that are available on all Dagger types. So a container has lots of things like with exec, file, directory. But in this case, we just want to get a specific file out of here. So let's say .file, and file needs a path. Makes sense. So pass. So the file
I'll
at this
just
path.
make a quick note that for people who remember Kyle's demo earlier on the shell, when he was typing these little commands that looked like bash commands, container, pipe, from, pipe, with new file, that was actually making calls to the same API that now this SDK gives you a client library for. So for example, container dot from would be one possible call, container dot with new file. Yeah, that stuff. So that translates word for word. Anything you can type in the shell, you can type the exact same chain of function calls in Go or in Python or in TypeScript, etc. because it's empty.
Yep. There we go. Yeah, so you're just chaining through the type of all its properties. So now there's a file there, and I can say, what are the contents of that file? So yeah, we're just chaining the same way we encode as we were earlier in the shell. So we see this super useful function contents to actually see the contents of a file, which sounds like what we want to do over here, right? So we have a file at that path, and we want to actually give the caller back the contents of the file. So that takes in a context because it's Go. So we'll do that, which means we need another argument. And then this returns a string and an error. So if it fails, we'll get an error back, but if it's successful, we'll get the string contents of the file. So that's what our function is going to return as well.
If you're watching and you're not familiar with Go, the context is just a Go thing. It's not important for Dagger.
Yeah, if you're working in like Python or TypeScript, this will basically be an async function. So in TypeScript, it'll return a promise. In Python, you'll have to await it. So all the different languages have their different funny ways of handling like different I/O. So anyway, we've got the read function done.
When you're done, you should show them your agent that you wrote that translates Dagger modules from one language to the other.
Oh, perfect. Yeah,
that's a cool one.
Yeah, the cool thing with Dagger is like I can use any module written in any language because it's all just converted to this client that I can chain these types on. But also, like when I'm working with the documentation for Dagger, for example, we want to show this exact code in every different language. And so I have an agent where I can pass in a Dagger module, and it'll give me back the same module, but in each different language that we want to support in the documentation. So yeah, I'll show that at the end. It's a pretty cool little bonus. But yeah, we've got a read function done. So now we just need our write function and our build function, and they should be pretty easy. If you want like to see a completed version of this in Go, I can have it linked over here. Kind of the thing we're building towards, roughly. So for writing a file, we want to take in like the path of the file once again, and then the contents to write to that file. So let's say pack contents string. So we have two arguments, and we're going to give back. Well, let's see what we'll give back in a second. So the first thing we want to do is say m.container. And remember, this is a builder pattern. So we're container is not being modified in state. We're going to say m.container with a bunch of new things, right? So with new file, path, contents, not context, contents. Okay. So yeah, this is like the builder pattern that I mentioned. So this, we have the container, and now it's the container also with a new file. And so we'll save that back to our container that's in our state. Now we want to be able to chain on this like we're doing with all these other types, is to actually return M as well. So when we return that modified state, and so that means this will return a workspace. Okay, so hopefully this is simple enough so far. We've made our first two tools. We have one more to create. And this one, we're just giving the file contents. This one, we're just modifying the state. And so this last one, basically what we want to do is just make sure our code in the container builds, right? So we can say m.container dot, and this is where we can actually execute a command. So we can say with exec, and with exec takes a string array of args, just like you pass to any other container, right? And so now I can say go build and that. So this is, if you're not familiar with Go, this is how you say like go build my current module, whatever the default module is. So we've got our command, but what do we want to actually give back to the caller of this tool? Because remember, this isn't, we're not trying to get back the built artifact. We're really just saying like, does it build? Like, is my code valid? So what we can say is just give me the standard error of that execution. And so if it fails, we'll give back the error message from this build. And if it passes, it'll just say, nope, we're good. So now this returns a string and an error. So we have to give it a context. And ctx context. And we want to give back an error, right? So we want to say, if it failed, here's the whole error object. And again, if it passes, we're good. So this returns string error, so we don't care about the string. We just want to return the error if everything failed. So we'll say error is that, and then return. Okay, so we're almost done with this. We've created our 3 tools. Yeah.
And I just want to say something about that second function that you wrote, just to make sure everyone understands how cool this is, and also it's an important feature of how Dagger works. The fact that the function writes, it modifies the container, but it does it in a particular way. There's no mutation, right? It's returning the new container. It's basically creating a new snapshot that is a modified version of the previous container snapshot, right? So Dagger manages the state of your objects, but it manages them like a build engine. It's building the state one change at a time, one function call at a time. So when you look, that gives you this very powerful property that everything is repeatable, because when you look at a Dagger function, you see inputs, right? That's the arguments. And you see an output, which is what's returned. And that's the side effects. It's not going to modify halfway through, like half of the object is modified, half of the object is not modified. You don't know what state it's in. There's none of these complicated state management problems. Dagger has this clean foundation where you're just building one snapshot at a time of your objects. That's why you see this very distinctive shape of this function, the lines 21 and 22. You modify and then you return. If you don't return the modified workspace, it's like nothing happened. It's ephemeral by default.
Yeah, exactly. And like one cool thing to point out here too is like the building blocks that we talked about so much earlier is that this is all just using core components of the Dagger API, mainly things based around the container type. And so we're using that as a state, and we're exposing these 3 tools that do specific things with that state. But we're not just giving the agent the entire container. We're giving this very narrowed down interface to say, here's how you read a file, here's how you write a file, and here's how you build. Where we could just let it try to figure it out and call these exact functions itself, but it's way too open-ended where it can also do all these other things that like obliterate the container itself and like just go down these invalid paths where these are the tools, these are the right ways to interact with your workspace in this case, right? And we have one more thing to add to our workspace. We're almost done with it. But we've, again, given the tools to read, write, and build, but we don't actually know what this container is yet. So we need to initialize it with something. Because remember, we're writing a Go program, so let's make it a Go container. So I'm just going to create a constructor for our object of workspace. So I can say func new returns a workspace. And so this is a constructor for my type workspace. I can say return workspace. And your container is going to be a dag.container, of course. So now it's a container type. But we want it to have something. Like we want it to be, just like we saw earlier in the shell, we want it to be from something. So let's say Golang. And so now we have all the Go tools in this environment. And we want a default working directory that makes sense for building a Go app. So we can say with workdir is /app, which is like the proper Go place to put that. Okay, so now when we create a workspace, we now have a initialized container that's the Golang image and a predefined working directory. And then when we call any of these functions, it'll mutate that container or really give us new containers with a mutated state, right? And so we're building on this container in our state, and we have a way to validate if our Go program's done. So all that was cool. We made our first like fully functioning Dagger module that we can now use in this other module that we're creating. And so we're back to our agent now. And so what I want to do is actually, or I'll stop opening that terminal. Over here in my terminal, we're just in my main module. I want to say Dagger install that module that we just created. So I say Dagger install workspace. And now what's going to happen here is that that object that we just wrote is going to be automatically generated and expanded my Dagger API. So remember we have our Dagger client here that interacts with the Dagger API. That's going to be expanded to now include the new type called workspace that I just created. And so now we can actually create an instance of a workspace. We can say workspace is dag.workspace. And so now we can see our new type that we just made, right? So that's super cool. But also, remember, we have all these types that can be inputs and outputs of an environment. So now I can say with workspace input, and now this has just been generated based on the new object that we just installed. So you can imagine when we looked at the Daggerverse earlier, all those like thousands of different modules full of objects and functions. You can install any of those, and that will be generated here where you can just give it to an LLM in its environment and have all of its functions available as tools that can be called. So this is like the real magic part of what we're building here. And so we have our workspace. It is just, we just create an instance of a workspace. So we'll call it something like workspace. Sure, I guess. Naming is hard. And then we pass it in. And then the description. So remember we talked earlier about how the description here, we're really building up our prompt in this declarative way with our inputs and outputs. So I can say the tools to complete your assignment. That's now when the LLM sees all of these things in its environment, it can say, okay, this thing I think based on my information, I think this contains all the tools I need to do this thing. So we've kind of hinted along like what these inputs and outputs mean. But the cool thing is, yeah, now this is not just like a big blob of markdown that lives somewhere. This is actually in our code in a way that's like really readable, just like your code comments are meant to be, right? This is like, what the heck is this input? Oh, okay, it's the tools. So anyway, enough rambling. Let's say one more thing. So we have our input of our workspace and our assignment. So those are our two. I guess our assignment and the place that needs to build. So the one more thing we need is an output. Because remember we have to return something which is our completed assignment. And so let's say with workspace output. And so we're just going to return the completed workspace. And now with output, it's a little bit different than these inputs because now we don't actually give it an object. We just say this is the output's name and what it's supposed to be, because the LLM is actually the one coming up with the variable or the object that this output is. So we'll see how that kind of comes together in a minute. But we'll say this is called completed, and the description is the completed assignment. Sure. Okay. So we've got our environment. We want to now mesh it with our LLM and say, here's your environment. So we had our with prompt. Let's just say before that with env. And so now we have, this thing is basically an agent. We'll have to work on this prompt for a second, but this is basically it, right? We have our LLM in the environment, And within this space, it's going to be able to do that diagram that we saw earlier of like going through the cycle of like calling some tools, making some changes, getting some feedback, and iterating until the LM's decided that it's finished its work, and then it will give that back to us. So the prompt, I'm just going to cheat a bit here and copy it from that quick start that was linked earlier, and we can talk about it. Okay, so here,
Cal,
yeah.
Can you go back to the workspace for 1 second? I just saw a question from Andreas that I wanted to address real quick. I think if you scroll just a little bit higher, like that workspace, the type itself, that's an object with fields like any other object, as long as it fits in the Dagger type system. There can be any number of fields of any type. It's not just that one container necessarily. Like you can have the assignment be there as a string. You could have a variety of configuration. You could have, secrets, all sorts of data in there. It's the workspace. It's an instance of a workspace that you're defining. So when you're writing, then that write function, you're modifying. It happens to modify one of the fields of the workspace, but it can modify any number of them, and then it returns the modified object. So I wanted to take a minute to mention that because there's one type in the Dagger type system that we use a lot, and it's container, because it's fun, it's flexible, you can do a lot with a container. And so sometimes people mistake that, they get confused by that and think, well, Dagger is like a container build tool and that's it. It's cool, it's got an API, but it's basically like Docker build. But it's much more than that, because the container is just one primitive, one of many types that you can program, like you can program any sort of software. So I just wanted to point that out. This is a very flexible system, and your object type, like the workspace type here, they can really contain all sorts of data, not necessarily a container being built.
Yeah.
Sorry, Cal.
Yeah,
I just wanted to mention that because I know that is a question that comes up a lot, and people sometimes miss that important detail.
Yeah, that's perfect. So yeah, this is just an object, right? We can put whatever we want in it, and the main thing is we're just using that state, which in this case is a container, but it could be lots of things, to modify the state of our object, and accomplish our task, I guess. But yeah, the write function could be confusing since we just have that one type in our state. But yeah, you can imagine there's lots of different things that could be happening there. And maybe we can show some more complex examples later on too. But yeah, so we've connected our environments with our workspace and our assignments and our output to the LLM. So we've got the main components of our agent, and we've got the prompt. And this is where if you're using like a small local model, you probably add several more lines here. If you're using a great big model, you could probably delete a few lines. So depending on the model you're using, you kind of have to figure out what makes it focus on the right things. And you'll find that a lot of different models behave differently to different kinds of prompting. So it's a bit of like trial and error, but also just learning. If you're using a specific model for a lot of your applications, you'll kind of have a specific prompting style. Hopefully this prompt is like general enough that we can kind of get things to work on whatever model you're using. Again, if you're using like Olama Quen Coder like 0.5 or 3, you probably have to add a bit more. But to kind of go through the different parts of this, we start by telling it it's an expert Go programmer. LLMs love to be complimented. They love when you tell them how great they are. This kind of sets its mindset to say, okay, when I'm solving problems, I'm solving them from the perspective of a expert Go programmer. So I'm not a TypeScript developer. I'm not a blogger. I'm a Go programmer. Because remember, we're trying to complete like a Go programming assignment. And then we tell it you have access to a workspace. This is one of those parts where if we had a really smart, capable model, maybe we could delete that part because it can already see from its inputs, like here's your tools. It's in this thing called workspace. Um, we tell it use your default directory in the workspace. Um, the funny thing for that is like this is one that I added as a line just by trial and error with different models. Is that in our workspace? Remember we set like the default worker, and we're just assuming when we run Go build that we're in the place with this Go program. But sometimes different models without that prompt would try to put things in like subdirectories, or they try to do some other fancy things. They try to be too fancy, right? So we're just saying, just use the place you're at. Like don't worry about that. And then don't stop until your code builds. This is like the critical piece of that cycle of performing a task, getting feedback. We want to keep going until that build completes. And so we don't just say, it's not just going to write a file and then come back and say, cool, I'm done. It has to actually make sure that that build function is run and successful. And then we say, your assignment is assignment. And this $sign will get expanded to this variable automatically. We'll see that happen. Cool. So now this is our entire agent really right here. Like we've done some work to construct our workspace and write our first like other Dagger module, or our more generic Dagger module. We've done some work to construct the environments, but now we've plugged everything together, and here's the agent. So now what we want to do is return that completed assignment. So now we have on our LLM, we have our environment with all the outputs and all these things. So we can say we're going to actually return work, which is this variable here, which is an LM. And so in that environment, we want to get our output called completed. And that output is a workspace. This like casting thing is just kind of implementation detail of how the different types that can exist in environments end up coming out, because we're just saying this output is just a variable name completed, but because we're using Dagger and it's a strongly typed system, that's one of its key features. We want to make sure that that thing at the variable completed is actually a workspace and not a string or something else, right? So as workspace, in our workspace, remember, we have a container. And I should have named this something else so it's more clear here, but we're going to reference this field called container at container. And so this is the field container, not the type container. And this now is our whole agent, right? So it's everything looks green. We've written an agent in Go that can solve a Go programming assignment. And I think we're ready to run it and start experimenting with it. What do you think?
I'm ready. I'm ready to
Okay.
go.
Let's see it. So I'll pop this open and we'll say, get back in our Dagger shell. And now if I say .help, I can see all the things that Dagger has, but also I'm in this module with this Go program function. So I could say .help Go program.
New function appears.
A new function appears. That's right. It's our first Pokemon card in our collection of platform builder agents. And so we have the usage here. We can see that it takes in that assignment, which is a string, and gives us back a container. And it's describing what a container is for us too. Okay, so now we can actually, let's just run it. We say go program, and we'll start with an easy one, the one that we always use. In this example, say create a curl clone. So hopefully it'll take that, and oh yeah, there's my 1Password prompt, and we can see lots of things happening in Dagger. While that's running, let's actually pop this open in Dagger Cloud so we can see a nicer. Okay, there we go. Okay, so lots of things scrolling by. It's trying to create its application over here. It's running into errors, which is expected, and hopefully it can figure it out. But as it's running, we can actually see with Dagger Cloud the visualization of this thing. So let me expand this and zoom in a bit. So we can see the same thing that's happening on the terminal, but over in cloud. And this is really nice because one thing that Dagger provides that you really don't get anywhere else when building agents is this visibility into every step that's happening inside the agent, right? So we see the little person emoji gave this prompt, and this is the thing we wrote earlier. And we can see that our assignment was substituted. And it says, your assignment is create a curl clone. It says, okay, I understand I have to create a curl clone using Go and make sure it builds. So it understood the assignment. It loaded its workspace and says, okay, cool, I have like this workspace where I can develop code. So I'm going to call this workspace.write function. And so now we've got tool calling happening. But the cool thing is with this, I can actually drill into this and look, oh yeah, I called container.withNewFile. Remember that function that was in our workspace code. We can actually see the code that our agent decided to write. So it wrote a main.go with these contents. And so after that, it tried to build, and the build failed. And then we can look into this and see, okay, so it failed because it's not a Go module yet. It's just a Go file. And so it says, oh, there's no go.mod. I need a go.mod. So it called workspace.write again, created a go.mod with these contents. And it tried again. It says, sweet, it was successful.
Can you open one of those write calls to show what the write function does under the hood?
Yeah, sure. Yeah, we can.
Oh, you should.
Yeah, we'll look at that. So we saw the container.withNewFile, which we had, of course, over in our workspace. So that was this thing happening here that we created in our code. We're seeing that write function being called, and then that's what's happening under the hood. So you can imagine as we get more layers on top of this, you can drill all the way down and see all the operations happening from that tool call that the agent kicked off.
And if you're curious, there's a little detail that people miss, or they assume it's just some random thing. But if you notice, each of these function calls at the top right corner of the box, there's this weird little drawing. And this weird little drawing is actually a really genius and also very funny little detail. It's a unique visual representation of the ID of that object. So since the object, every value is immutable, like I was explaining before, right? Like a function returns a value, you can't modify that value. It's got a digest, it's content addressed. You can only produce a new value that is different. That means that that digest is the ID, the unique ID of the object, and these little space invaders are the visual fingerprints of that object's digest. And I think if you click on it, something funny happens. Oh, you just clicked on it, right?
Yeah, I think that's of it, maybe from the zoom, because we have the little box bit away from my cursor, but that's live demos for you.
You can you can expand it and see what's inside the object. But yeah, I think the color, there's something also, Alex is the engineer who designed this thing. He could probably explain, but I think the color is the type, right? Like containers are blue. I think that's it. That's what it is.
Yeah, we got a few different here.
Yeah. Anyway.
Yeah.
I love that detail. I don't use it as much as I should.
Oh,
the color's the type. Alex confirms.
Nice. We've got Alex in the audience. Hey.
He's in the audience. Yeah, he's shouting responses. The color is the type.
That's right. So yeah, it looked at first it looked like it went off the rails a bit, but actually this is something interesting that I've seen a lot of different models do, where it, as a starting point, created almost like our Dagger and AI, it created like the scaffolding for the program, and it's not yet implemented, but it wanted to make sure that it's going down the right path first. So it said, okay, I've got some arguments, and I haven't yet done the actual curl part yet, but here's my program. Let's see if it builds. And then it figured that out, and then it builds. Okay, now it says, now I need to implement the actual HTTP request using the net HTTP package. And so now it did that. Very cool. Let's try building again. And now this is going to fail with a different error. And it says, On line 7, string literal not terminated. So let's see if we can see what that is. Oh yeah, so it's missing a quote here. So it's still just generating text, right? Our model is still just doing dumb model things, but it'll figure this out. It says, oh, I messed up. Okay, let's try this again. And then it maybe corrected the error and ran. Oh, I don't think it actually. Yeah, it's the same error. But eventually, it looked like it passed. No, and it was unable. Okay, well that's agents for you. Let's let it try again. How about that? So we'll get a new Dagger shell and ask it the same thing. Create it. Let's say maybe it was less reliable with create. Let's say develop a kernel clone. You're a Go developer.
This
The
is
word
basically the life of AI engineers. You're just
I just keep
retrying,
throwing stuff at it.
relooping, tweaking the prompt. Yeah, that's why the having a rapid iteration loop is so important. If each iteration takes 30 minutes of moving knobs, resetting configurations, emailing someone, whatever, you're never gonna get a good result because you need so many iterations to get the perfect agent. You want these iterations to be as quick and painless as possible.
And not just that, but you need to be able to see what's actually happening so you can figure out like, okay,
Right.
it was really struggling with this validation for some reason. And sometimes they get themselves on these little paths. And you need to create in your prompt some more guidance to not go down the wrong path. But we're able to see all the way through that run, like what it was running into and why. And it just couldn't figure out like that it forgot a quote. But that's okay because we tried again, it was good. And we can see the UI, we also get like not lots of nice feedback on like how many tokens it's using. So if you're wondering why you create an agent and it costs like $10 every time you hit enter, you can look at these tokens and think, okay, something's going funny in the amount of context I'm passing through. So anyway, it says it completed it. So it's cool. So we have a container. And so if you remember earlier when we're just chaining types in shell, at this point I have a container. So I can do anything, including terminal like we did so many times before. And so now we're in this container. And you remember earlier we did like the with new file, hello kubesymfly, all these things. We're getting that same kind of container here. We're saying, okay, it's from Golang. It's got this worker that was the constructor that we made, but then the agent added these other things that are with new file main.go, with new file go.mod. And so if we look at here, I can see those two files that it created. And I can say, let's look at the main.go. And it looks actually like it's got a bunch of error checking. It's one of those things where like, oh no. That's so funny. It aliased IO this time to get around its little bug. But we know this will pass because it passed that build step in its run. So we know this, it got there one way or another. Sometimes they're a little bit funky with the way they arrive at it, right? Like Jeff Goldblum says, like life finds a way. So it's gonna find a way to create this task, whether it's the most ridiculous solution or the cleanest solution. So I can actually say go build, and then this should create there it is, my main. So I can say main, and it's telling me, okay, I didn't pass anything in my usages, this, right? So I can say fine, go run main.go, and we'll give it hvs example.com, file already closed. Okay, it failed again. That's so funny. Okay, this is like the most basic of prompts, but we'll give it another shot. I don't know what could be different other than it just needs to. It just maybe it's because Google Next is on right now, and Gemini is super busy or something. Who knows? But yeah, we're
Are you trying another model?
no, it's the same one. If it I don't know if I missed something. It's still failing. It's so funny. All right, let's.
I mean, let's try it. Let's try a model showdown. It's a good chance to show how
Sure.
easy it is to switch between LLMs because you're not. This is not. I mean, I'm sure, I hope the Google people are happy that we're showcasing Gemini, but this is not a Google only tool.
Yeah. So let's if I look at my so I've got a bunch of different configs here. So I could say, let's
You're
see.
so confident in printing those files.
Oh, with one password integration with Dagger, I don't have to worry about putting secrets in my configs, right? So I have this here. Let's point this at this Olama machine in my configuration, and that is, and you can see I also have a setup for Docker model runner. We're not going to risk it with all the different things I'm running on my machine right now to try and run a local model too. And let's say the model should be the one I have in 1Password as well. I like using 1Password not just as a secret store, but also like a config store, right? So I have like my Olama host, Olama model, and these are pointing to these URLs. So now if I go back into Dagger and say LM model, and this should say whatever I've configured. Yeah, Quencoder 32B. So this is a bigger one versus like the 7 and 14 that we saw that were available with Olama. Okay, so now let's try again. Let's say develop a curl clone. Google's really busy right now, so let's not bother Google. Let's use our model and let's see how it goes. So now we can follow this one again in cloud. So it's got its prompt, it's thinking about it. 32B is relatively large model, so it takes a second to spin up, basically. Like it's got to load it all into Olama. So I've got so many different models that are sitting there, right? So it takes a second at the beginning to actually load that model. And you can use different tricks and stuff with Olama or whatever model runner you're using to actually keep the models like hot and ready to go. But this one is not stuff like that. So we'll wait a second. Anything to bring up while we're waiting for this to run? It should just be a second here. Questions? It all makes perfect sense.
There's a comment saying, I tried with Quen, but it failed.
Okay. Well, we'll see. We got Quen 32, the powerhouse. Yeah, and
sometimes different models need slightly different prompts. The prompts are usually not fully portable across models.
Yep, exactly. So yeah, I think we kind of touched on that too, is like the difference. Like we had this default one here from the quick start, but if you're using Quen, you might have, or like a smaller version, you might have to say like always return the result or something like that, right? Like give it a bit of nudging to actually complete its task. You're not constraining it. You're not telling it exactly how to complete this task. You're just like narrowing in those guardrails to say like, seriously, call your tools, seriously, make sure it builds all these things. Like, there we go. So it's up. It did the workspace. It tried to call build first. Okay, now it's going to write a program. Very nice. That looks like a curl clone. All right. Yes. What's this? Okay, so we did the thing, kind of. So it says we did it. It created that, and then we ran into this issue where it didn't want to return the object. So this is like literally what I was typing right here. Always return the results. So we'll get out of here, try again. And now it gets right into it because the model is already loaded. And we can watch it here in the terminal this time. It'll be great. Okay, it tries to build. It hasn't written its go.mod yet. So hopefully it figures that out based on this error output, right? It says, oh, I'm missing a go.mod. Okay, let's try that again. If this one fails, we'll try Anthropic. It's going to be the real showdown of things breaking on live demos. It's so funny because this particular demo, at least in my cases with Gemini, it's like 100% of the time it works great. And then you throw more complicated things and the wheels start falling off. Uh, and that was like next up on the list is like give Gemini the more complicated thing and see how it goes. I mean, literally an hour ago, that's how it went. And yeah, we got Quen failing. Okay, let's forget Quen. Let's go. Look at that. I'm just typing env in my terminal too because we don't put actual passwords in there. Let's go with this Anthropic one. Okay, so now going back into here, let's say lm.model again, lm pipe model. So I've got Claude 3.5, and let's see how Claude 3.5 does with developing a curl clone. They all seem to be struggling today. Just the way it goes. This is the magic of AI, in case anyone hasn't
Magic of AI, yeah.
stepped into this world yet, is it's non-deterministic, and that's the feature, right? That's kind of the point. But sometimes you're doing a live demo and things don't work, and that's also the point.
Yeah. This is where you're very happy you have a modular collection of agents as opposed to a big monolithic thing. Because if there's an issue in the big monolithic thing, that's it. You can only click refresh and try. But if it's modular, you can run the module somewhere else. You can swap out components. You can just do it in the command line or do it from CI or whatever.
All right,
Claude
saved us. Yeah, so we
nice.
curled example.
So which models?
This is Claude.
Which models did you try?
So we tried Gemini, which is having a day, I guess. We tried Quencoder.
They just launched their new features today. Maybe that's why they're getting hammered.
Yeah, exactly. Yeah, I think for Gemini, it's a big day, and maybe if you're doing live demos, don't go on Gemini for a few hours.
Jeremy says that it worked for him on Gemini at home.
Yeah, he was rolling the dice. But yeah, so it would work with Anthropic. So now let's try something more complicated. Let's say develop a terminal Pong game. And so now it's really going to spend those tokens. But thankfully, my token is on the Dagger team account. And so as we burn through these tokens and create our Pong game, it's not coming out of my wallet. Sorry, Sam.
Do you want to, Cal, do you want to show the homepage of our Dagger Cloud org, like where all the traces are flowing through?
Yeah, so you can go back here and say, back to Dagger. So you can see, actually there's Jeremy. He said that it worked for him, right? So we can go see how Gemini worked for Jeremy. Let's see. Looks like it understood. And it wrote that. It did the build, which failed. And then it wrote its go.mod. They created. Nice. So he's not lying. He's telling us the truth. Thanks, Jeremy. And we can go back and see lots of other stuff happening in the whole team. Yeah, exactly.
Works for agents and for humans.
Yes. Yeah, we can see all our CI runs for Dagger as well. But yeah, all the stuff that people are running locally across the team. Oh yeah, there's yours. Are you gonna run something cool?
I don't know. I was just gonna try doing it from my version.
So you're going into
the first time I watched a trace of myself via live stream. Go program.
That help? What did that give you? Okay, so you've got
write me a curl clone
available. Okay, yeah, so it's pretty similar. We've got a few different prompts here happening. It's selecting the workspace. Oh yeah, and in your toy programmer, if I remember correctly,
it's an older one.
A file, right? So it writes that assignment as a file that can. and then basically the same like trial and error flow where it like creates the go.mod, creates the main.go, tries to build, and it's like, oh yeah, I need a go.mod. And this is one of those things where like if you're watching this, if you're building an agent for production, you're watching this and you're like, okay, every single time we spend an additional like 1,000 tokens because of this first step where it trips and then creates a go.mod. Maybe in the workspace you pre-create a go.mod, right? Like you can use this observability to actually make these runs more efficient and cheaper and all these things. And so it created your curl clone, and now you're in a terminal. Okay, so I can see what you're doing in your terminal. Oh, you're typing. Nice. So you're in a terminal that contained. Oh yeah, you curled. Maybe
Yeah, it worked.
Yeah, awesome. What model was that with?
That was good question. GPT-4o.
Nice. Cool. Should we see how the Pong game went? So it says it's done. Just say go run may.go and see what happens. Oh my goodness.
Ooh. Wow,
Okay, I don't
that
know
was
how to
pretty
play
good.
this. Uh-oh, I'm gonna lose. Oh no.
Wait, I
Okay,
want to watch your Pong game in the
give me a
trace.
I've been set up. It just wants to run up the score, AI versus player, right? It's like, okay, AI's got this. Humans are going down. So this is the general sentiment we're getting from Claude today. But this is hilarious. Super cool. Um, so yeah, that was the main flow of what we wanted to show is not just me being tied up here while an AI beats me in Pong and I can't do anything about it, but also writing an agent with not a ton of code, right? Where we have this kind of one screen. This is the main agent. The workspace we made was kind of a side quest to understand how you can write a Dagger module or write really any object and expose all of its functions to that LLM, right? So you made your first module that is its own self-contained thing, but you can also, go to the Daggerverse and grab any one of these modules and give all of their functions to now. Like you could K3s, for example, you could grab this, and this one can actually run like K3s inside of Dagger. And so you could give a whole cluster to an LLM and say, like, go have fun, and it can call all of these functions, like get the service itself. And yeah, this is the main code. Like half of it's prompting and comments. And if we have to add more prompting for smaller models, like you can look at that tracing output and figure out what needs to be adapted, what is tripping on commonly, and then adapt to that, right? I don't know what else do we want to shout out. Like we have within Dagger this really cool system to actually test these things on different models. Should I show that, Solomon, or is that kind of a cool Easter egg people can discover on their own? What do you think?
Oh, the evals?
Yeah.
Yeah, it's either the evals or the maybe would it be easy to just call your translator module and have it translate this module to another language? Do you think it'll work?
Oh yeah, we could try. The AIs are not on our side today. It's still beating me in Pong. Okay. Cool. So
Yeah, the
let's
evals are
get
pretty cool. So yeah.
yeah. So yeah, I have a module over here called Dagger Programmer. And so if I zoom that in a bit, it's just like we described earlier, like it's just another Dagger module that looks like an agent, like that, like the one we just made. And I can load the module and basically give it my code to translate, right? So if we copy this, and we'll just actually run it and just see what happens. So we load the module. I guess I have to update the README with a dot. I guess that it was that changed recently. Things are moving fast. But
Is it
basically,
ever CD without the
my
dot? I
shell,
don't even remember that.
yeah, maybe not. Maybe I'm hallucinating things as much as the models are these days. So now if I dot help, hopefully I'll see that here. So now I've got the translate and the right examples functions that are in that model that we just CD'd to. So this is like just any module in the Daggerverse in shell. You can just switch your current context to that module, and now you've got all of its functions and tools, right? So now one of those is translate. So I could say translate my current one, and we'll see if that's correct. Oh, we need to tell it what language to translate it to. So we'll say Python. All right, so that's going to run. It's doing lots of things. Let's actually look at Cloud for this as well, so we can see the really nice UI of what's happening. So again, we're further down in this session. So this is our attempts earlier of it beating us in Pong. Okay, so now we told it translate Python, and we gave it some information on the Dagger Python SDK. So like, hey, here's some quick tips on like what Dagger Python syntax looks like. And we did, so now it can actually look at our module and then figure out how do I get it into this format and write Python code. So now it's trying some things. And it gave us a directory. Okay, so what is that directory turn? I've actually never run this with Anthropic, so let's see what happens. So now we've got a directory type, so we can chain lots of things onto directories, right? Like with files, digests, whatever. But I can also grab a terminal in a directory, which is really neat. So now we're in here, and in this terminal there is a source coding agent and my main.py. Let's check it out. Source coding agent main.py. Okay, so we're not.
That's so cool.
Let's see. Actually, let me put this back on my machine so we can look at it with like syntax highlighting and side by side. So we can say, instead of terminal, let's just say export that source. Was it coding agent main.py? Right here. Oh, export.
You have two paths, right?
Receive to. Oh. Okay. There it is. So let's look at these side by side. We might have to zoom out a bit. So I've got the same function, but in Go and Python, right? So this is just another agent that I've made for my army of robots that help me with the tasks that I do like day to day at Dagger. And you can imagine like all the kinds of things you could do for your own workflows, like all these things that us as platform engineers are famous for, like automating everything we do with scripts. Now you can have even more complex tasks that have less constrained guidelines, like this more open-ended, like, okay, you've got a thing in Go, it needs to be in Python. Like, kind of good luck doing that with a bash script, but now you can add a little generative capabilities into your little flow. And now I have this thing, and it took me, I don't know, maybe a day or a couple days to make it working perfectly. But this is correct Dagger code that shows the same thing in two languages. And thanks for suggesting that, Solomon. I did not prepare that before, and it just worked.
I'd never seen it in action. Can you try the examples generator also, because that's also great. Yeah. It's a great use of LLMs because it's not deterministic. That's the whole point. That's something we just to set the stage while Kyle gets that agent.
I was going to show like what examples are.
Yeah, go for it.
Yeah, in Daggerverse, like we still have those modules, but you want to actually write some code samples for how to use your modules, because by default we generate some code that says like here's the type and the functions or whatever. But as this module author, you want to write a really great example that shows like how do I actually use this module. And so that's kind of a manual process today. And also today you need to actually write that in each of the languages, right? And so, okay, you start thinking, I wrote a module that can write things that take one thing in one language and convert it to another. What if I could generate an example in one language and then produce it in all of the language for all these tabs? And now, as a module developer, you don't have to maintain all these things. You just have your agent kind of do that for you. Um, and so this is also a capability of this Dagger programmer agent, right? Where we said the help, that was the write
Oh, it's the same
examples. So
agent.
same
Yeah,
agent.
got it.
Say write examples in all supported languages and give us back the directory containing them. And so the example for Go programmer might not be super complicated um, because it's just got one function, and usually with examples you might have lots of functions that can be used in different ways. But anyway, let's see what it comes up with. So if I say help for write examples, it says, okay, I give a module and it gives me back a directory. So that's it. So I can say examples, my module is dot. So this refers to like, just like in any shell, that's my current directory on my system, right? Which is this module that we've made over here is where our main.go is where we open the Dagger shell. So that is
Isn't
the
that going to
Dagger
apply to
module.
the? Isn't
Oh,
dot
yeah,
since you
it
change your
doesn't care
context
about
to Dagger programmer?
no, it doesn't care about that. It's just pointing to my file system, right?
Okay.
So it
It would be
knows.
funny to see what that agent
Yeah, if it
does.
wrote examples over
See
here.
it generate examples for using itself.
Yeah,
It's hurting
it
my
could,
handle.
right? It might even have done that. I'm not sure. So we can say write examples, and then it gives us back the directory, so we'll get a terminal on that. So this is where everyone needs to like give their good vibes to Anthropic right now to make sure that we get through all the different stages of this, because this is a multi-agent workflow here where it's looking at um, how do I write an example for a module? I have to understand the module, which is our Go programmer one, and what its schema is, so I can write examples for those functions. And that's one agent just to write a Go example for our main.go. And then we actually spin up several other agents that take that example and translate it, right? So we have this little multi-agent thing where they're each specialized to either writing an example or translating. But we're not giving that to one big LLM and say, figure it out. We're actually splitting that up and say, okay, this agent actually translates from Go to Python. And so you can solve that. And this other one does Go to TypeScript. And so we have this little DAG of agents now, and they each have their own DAGs of the things they're solving, and they're each connected up to different models. I can bring up the code while it's running. Just going to think about it for a second, I guess. I guess that's understandable. It's kind of a complex task, right? This one's written in Python. And let's see. So in our translate function, we're going to figure out the module we passed in and its SDK. We're going to create an environment that has a bunch of inputs and an output. So just like we did with our really simple agent earlier, where we said, here's your module workspace, which is another like specialized set of tools I gave it for writing Dagger modules. Here's some information as strings like the SDK, the module file itself, the language it's in, and you're going to give me back the module workspace. So really, this is the same shape of the agent we wrote, but it's just doing a slightly different task. And then we give that all to the LLM, and then it does this thing. And we can see some, oh, we're actually in it completed. Oh boy. Okay. So in this, we've got our Go example, our Python example, and our TypeScript example. Let's see what they look like. Cat examples, Go, main.go. And so it showed it, so it made a Dagger module. Because examples are also Dagger modules that show how to use your module. And it says this example is our coding agent Go program, and then it's going to give back dag.codingagent.go program, write a hello world program and go. So this is actually a valid use of the agent we just wrote in Go code, right? Because remember, when we install that, that's going to be added to our Dagger client as coding agent. And then that function go program takes in a prompt and returns a container. And we can see this function returns the Dagger container. And if we look at the Python ones, for example, or let's look at TypeScript examples, TypeScript, source index, it's the exact same. So it was successfully generated in Go, and then the other agents translated it to the different languages. So there's DAG coding agent. We can see it's got the proper casing for TypeScript, and this would actually work. So now, again, if I'm doing this as a Dagger module developer, I can say export this here. And now in my module, I've got my examples in their correct paths, and this will show up in the Daggerverse just like it's supposed to. So yeah, super. And it even got the dependency correct, so this points back to my main.go module. And I think we can finish skimming through the module itself. So like we saw with the translator, we gave it all these things. After it finishes, even though we ask the LLM, like make sure your test passed when you're running things, we still do that again. You know, sometimes it'll fail the test 100 times and be like, I don't know, your test function's broken. Here's some output. So we do want to make sure manually that that our checks or whatever validation we have pass, and you can still use that exact same code you gave to the LLM. So it's all just Dagger functions. And the right examples one is kind of a similar flow where we like get some example or get some information about the module we passed in, like its SDK and its schema. And then we put that in an environment. Say your input is that Dagger workspace, and here's the schema, and you're going to give us back the generated example. And once it generates that example, and again we manually validate that that example's good, then we can actually go through and say, okay, we have a directory with this first example. Let's loop through these other two languages, and we're just doing this in Python code. We're just saying in each of these different languages, call this other function, which itself was an agent. So now we had like 3 different agents basically to create those 3 examples. And it worked, which is pretty amazing, especially with how much we tripped on creating a curl clone earlier, which never happens. So yeah, that's kind of the intro to building agents, I think. And you can kind of get some ideas of the things that you can build for your own platform and start building your army of robots. And we have this simple example that teaches you kind of the building blocks that you can then take to expand and build these things and interact with. Like we talked about before, like Grafana or other parts of your platform that you want these bots to be interacting with.
Oh, I think you're muted, Sam. We can't hear you.
All right, I think now it should be.
Yes.
Yeah.
Ah,
All right.
Yep.
Amazing. I think that was cool. I was actually trying out, all that. I tweeted out as well. Trying out live workshop makes it more fun, to be honest. And that's what I did. So, and we had many people who are there with us, which is good, and who are hearing about AI agents, how to build one. I think there are a lot of ideas that I already got, how I will build the next agent and then use it specifically for um, writing some of the portions and then validating it using K3s module so that it actually run it on a
Yes.
cluster and validate it that it wrote the right piece, which is the technical piece and not just a theory piece out there. I think many use cases comes with this and with a toolbox that people can create. So yeah, amazing. And that's what I like
Yep.
about these workshops. They are open ended. They are, you do a lot of cool things. We saw the models failing, and then we saw how it works on some of the other models, and then some of the other cool use cases of generating examples and more complex ones. Yeah, I hope people who have watched live enjoyed learning about AI agents and build their AI agents or will be building their AI agents in the future, and the people who will be watching it later, it'll be
Yeah,
found.
I have one more thing for those
Yeah,
people
yeah,
too.
sure.
So if you wrote this module, or like the one I talked about earlier, where you have your self-healing CI, right? And you say, okay, I have this thing I can run on my machine, but how do I actually automate this on my platform and do all the things out away from it, right? And so that's where it's actually really interesting that we've already built all these systems, and maybe you just haven't realized it yet. And that's your CI platform working with your code base and your platform is already this really powerful event system that reacts to things happening in that ecosystem us as platform engineers already work with. And so you can think about the self-healing CI bot. It can actually just be run as a workflow in your CI system that happens when specific events are triggered, right? So you already have this production grade event system running in your platform. That's where you can just put your agent and say go run wild, but in your sandbox, and you don't have to think about how do I deploy this new system within my platform to orchestrate agents. You've already got it. So yeah, when you build some of these agents that you want to run in your code base, that's how you can kind of get that entry point.
Yeah.
Fancy. Well,
There's two future topics for people who are curious and want to explore more. Two advanced topics to think about. One is MCP, and the other is multi-agent, and they're related. MCP is something we didn't cover in this workshop, but it's something that's getting a lot of hype over the last 3 weeks, very recent. It's an open protocol created by Anthropic to standardize specifically the interaction between AI apps, AI clients, apps like Cloud Desktop, Cursor, Windsurf, and external tools. So it's like a plugin, like an open plugin system, and it's getting adopted widely. And it's most useful when you have, in the context of these agents we're talking about, when you have an IDE like Windsurf or other that, and you're already using it, and you're interested in external tools like Dagger, and you want to connect the two. All right. So far, we've showed you how to do everything in the context of Dagger, like from the command line. But Dagger can be integrated into an existing system. If you want to integrate into your CI, then that's what Kyle was just talking about. We have everything needed for that. And if you want to integrate it in Cursor or Windsurf, then MCP is the way to do that. Or the shell. Command line is always there, right? So Dagger has, it's a secret, don't tell anyone, but Dagger has experimental support for MCP. There's a command called Dagger MCP. It's not in the help message, I think, or maybe it is now. But you can configure your favorite MCP clients to run, you add a new MCP server and you say Dagger, and the command that you give to your client is Dagger MCP, and then you give it a module. Local module or remote module, and then it will automatically load. It'll do everything that Kyle showed you, but over MCP, and you'll be able to prompt your Dagger functions, interact with your Dagger functions through Cursor or your favorite tool the same way that Kyle was doing it from the command line. And we're going to do a lot more around MCP in the future. And the last thing I want to talk about is multi-agent, because Kyle showed creating an agent, right? So LLM plus environment, you connect them, and then you give them tools, right? Which are these little functions. So now the LLM has access to functions and they can call them. But that agent was itself a function. What happens if you write an agent inside a function and then you give it access to other functions, and one of those functions maybe also calls LLMs itself and gives it access to more functions? Well, congratulations, you just built your first multi-agent system. And multi-agent is also a very hot topic right now, and it's very mysterious and complex, except not really. if you can put an LLM in a function and an LLM can call other functions, that's all you need. So MCP and multi-agent, those are the advanced fun topics.
The next
if you want to
steps.
go beyond this workshop. Yeah, the next steps.
Yeah.
Yep. And CI integration, like Cal was saying, those three.
Yeah, one thing I want to touch over here is that there will be a MCP workshop this April itself from Eduardo, who is from Dilipso, and they are the creators of MCP.run, which is very fancy, very interesting. So yes, we'll be covering about what MCP is, why it matters in cloud native, then going towards the MCP run, what are MCP tasks, showing hands-on example and stuff. So yeah, stay tuned. You just need to be on Cube Simplify to simplify your AI needs as well.
Yeah,
awesome.
When you do that workshop, ask them to show you an integration with Dagger. It should be fun.
Okay, cool. Awesome. Thank you again, Solomon and Kyle, for taking out huge chunk of your time and doing this workshop. I'll be uploading this as a video so that it's visible inside the YouTube channel, because live streams are only visible in the live section. They're not visible in the videos. That's a weird kind of stuff that YouTube does. But yeah, I'll make sure that's done. And then people who have watched live till here, thank you so much for being with us. And see you next time.
Awesome. Thank you. Yeah.
Thank you.
See you in the Dagger.
Bye.
Thanks for having us. Bye.